Oh,
Yeah, and the rules.
yeah, dude. I was gonna say something before, but now I'm being interrupted. But yeah, dude, they are gatekeeping and safe spacing for newcomers. Matthew Learns would provide a valid globe argument, but they don't want people that are flat curious to hear that side of it. So they're creating an echo chamber. And that's why they don't like Matthew Learns. So I don't know why he couldn't just be honest to Park Punk.
I want to hear this valid globe argument.
Oh,
Right.
sure.
Yeah, no, there's things that
evidence
substantiate the
best.
globe model. Absolutely.
Yeah, the valid argument is that the mainstream globe heliocentric model provides better explanations for the observations. Therefore, it's more likely to be true.
So kinematics, not dynamics.
No,
Got it.
Explanations for observations.
No. Very specifically, kinematics and dynamics, bro. Just measuring the sky is what you're talking about. I mean, I remember the last. I mean, have you learned that the sky is the only place that you can't apply perspective, Mr. Mathew Learns? Did you figure that one out yet?
I don't know why not. I mean, the sky is part of reality. Perspective works in reality.
I mean, this is a beautiful example right here of how Mathew Learns is obviously a logical and intelligent being, and his inner being tells him, yeah, I should be able to apply perspective to the sky because it is an axiomatic principle. But very specifically in the heliocentric model, you can't do that because it's not perspective when you look at the sky.
You're saying there's an equivalence. That would mean that the globe model would work.
Well, you have to say that it's not perspective though when you're looking at the sky. It's something else.
Yeah, I can prove that things moving in the sky are not due to perspective in an argument very easily. All you got to do is invoke the idea that as things decline towards the horizon, they're also going to change angular size, right? And that doesn't happen to the distance between stars as they decline and you move away from them. So boom, no perspective.
Right, and the full moon stays the same angular size all night long, which indicates to me that it stays the same distance, which matches the heliocentric model. Now, when I say same distance, I mean within 2%.
So the cause of the stars declining is not due to perspective, if you ask me, because they would have to change angular size between the stars, like the distances between constellations. As it approaches the horizon, you would see the Big Dipper shrink. Never happens. At least not over the course of a day. Over the course of a year, that's different.
Yeah, because everything in the sky is apparent. That's really difficult to say. You can't say I'm looking at a physical object like you would, say a basketball that you threw down the street, and you watch its angular size change. Sky is mysterious in that optical way, but the thing about Matthew used the word explain, and very specifically that paradigm does not explain anything. It describes motion, and there's no dynamics for that motion that work. Otherwise, the law of gravity, or the theory of gravity, wouldn't be a theory, it would be a law. You see what I'm saying?
Orbital mechanics work. I mean, it works good enough to predict where things will be and to make satellites like satellite TV transmitters and GPS transmitters. So I would say it works pretty well.
So, yeah, I've been down this road kind of in
the sky for thousands of years, and then now we know where they're going to be. And it's like, oh, orbital mechanics works. Yeah, because it's fucking a pattern. It's been happening the same way for thousands of years. Of course, we know where it's going to be.
Correct, and this is where you need to draw this distinction between kinematics and dynamics in physics. Kinematics is measurement, just like Electric here just said. It's observations of periodicity in the sky, and you record those, and that's how you make the prediction is just from what happened before. But where it falls apart is things like perihelion shift and retrograde motion. There's no dynamic explanation for that within relativity at all. And so they're left to ad hoc things extra to make the math work. Even between general and special relativity are completely incompatible, So, I mean, it's important to learn the difference between kinematics and dynamics. And yeah, most observations of the sky are kinematic equivalences. You could choose them to interpret them from whichever reference frame you want, and you're still going to get a correct answer.
Yeah,
Because
one
of
of
the
the
way that we make
equivalences you're
maps.
creating is to a globe model. So you're saying, when you say that, you're saying the globe model can work.
Well, it's an interpretation of the curvature in the sky as related to the ground. It's called a kinematic equivalence. You know, you can look at it either way and still get the right answer. But like I said, kinematic equivalence, how you're viewing it, optics. And that is not dynamic in any way. It's just an observation of periodicity, like you just said. The only place you see curvature is in the sky, you know? And you have to translate that curvature to the ground to make the ground a globe. Does any of that make sense? Or does anybody have any questions?
Yeah,
I wonder why we can't focus on this thing about, you know, the stars declining due to perspective. Wouldn't that have to be the case as you move away from the star on a flat Earth? It's lowering towards the horizon because of perspective, right?
Yeah, exactly. That's exactly what I contend is going on. And the sky and the ground are coplanar, and the celestial theodolite proves as much. It's only with
Okay, so
okay,
so
go ahead.
typically
Sorry.
when you move away from something and it lowers in your field of view, you know, the distance is going to make the object change angular size and lower towards the vantage point. Is going to like approach eye level if it's like above eye
Yeah,
level.
exactly. But we're
Right.
not necessarily viewing an object. We're
So
viewing an apparent position.
you don't have angular size change. Like, what's up with that? How could it be due to perspective if you don't
Well,
also
it's
have angular
interesting though.
size?
Hold on. This is a great point because the spherical limit of our vision and the alleged radius of the Earth are identical. Now that's not a coincidence. To me, that's the fudging of the numbers. That's the hook. That's the curveball. You know, like, oh, it just so happens to be that the curvature of the Earth is the same as, you know, how we view with our vision, a radius of 3959. How
That would be due to
convenient for the
curves.
globe, right? Oh, yeah.
Wait, what
I
limits
see
our
a problem. I see a problem with this. Go ahead.
So the curve you're saying is there, but it's the curve of your vision, which is an otherwise axiomatic principle which applies to everything else in the world except for the sky. It's not perspective when you look at the sky. It's the exact same optical value, but it's for a completely different reason.
Wait, what limits
Does
our
everybody
vision?
get that?
I'm not aware of any limit to our vision.
You're not like, it's just simple perspective, like you were just describing to me. You know, you throw a basketball down the street and you watch it change in angular size as it goes away from you.
Right.
Let me
There's a
say this.
certain angular
So,
size that limits,
my bad.
but not a distance.
Let me say this, dude. So, you know, because of perspective, something below eye level is going to rise up towards eye level as it gets further away from you. And you're invoking at some point along that distance, it no longer continues to rise and then it starts to drop. So there needs to be some mechanics. Like when you invoke that, you have to know the math and the rate and whatever algorithm you need, whatever matrices you got to create. I don't know what you're going to do there.
0.02 degrees is the limit of your vision. So basically 0.02 degrees of the circumference of your vision, that's like a pixel. You can't distinguish anything that's smaller than 0.02 degrees.
Right.
So that's the vanishing point, right? So like when you're talking about something going away from you and appearing to rise to your horizon, or the opposite, you know, if it's above you, it's going away, things appear to merge into the horizon. I mean, it's the same old thing as, you know, looking at street lights going down a long street, you know. And this thing about perspective, you know, is, you know, I keep using the term axiomatic principle because that's what it is. You know, and you can go look up what, you know, fundamental axioms are. You know, they're
Yeah,
presupposed things that we
the
use so
stars
we can have.
declining don't follow your axiom. Like the axiom of perspective is Things change angular size over distance. That doesn't happen to the stars, so you can't apply your axiom.
Yeah. Everything in the sky is apparent. That's why. We're not necessarily looking at a physical object, and that's true within both paradigms.
So the idea is things are rising up towards eye level, and then the further it gets, they start dropping down. There would have to be some mechanic in the lens. I don't know what's going on.
No.
I can't describe
They
it.
curve.
If I
No,
could make,
they
if I could make this make
merge.
sense, I would.
It merges into what you call the horizon. The horizon isn't a physical place, dude. It's the limit of your vision. It's 0.02 degrees. I mean, I don't get why that's so hard to understand. Something's too far away for you to see it, and then when it comes into being close enough to where you can see it, that is 0.02 degrees of your 360 degrees of vision.
You're not addressing my question, but I don't want to have to ask it again, dude.
You keep talking about something not merging into the horizon and going somewhere else.
I'm talking about as things move away from you, they rise towards eye level. Over distance, it approaches the vanishing point or the vantage point. Then, if it were a flat Earth and we observe drop over distance, which is reality, at some point along the laws of perspective, things stop to rise and they start to drop. And I don't understand the mechanics of it if it's all based on the eye. I don't understand how the eye could be shaped to cause that effect.
I don't even think it's necessarily the eye. It's just that you're viewing from one point in space. You know? So the curvature eye is obviously a factor too. But at these distances, we're talking about just your viewing from one point in space, you know? Whether you use your camera or an eye or whatever, it doesn't matter. You know?
You agree we observe drop over distance at the rate of the radius of 3959 miles? You agree, right?
Like I said before, interesting how it's 3959 and that's the same radius of your vision. So you wouldn't even be able to distinguish between the two. Unless you did something like eliminate refraction with the celestial theodolite, which is brilliant.
How do you measure the
Yeah.
radius of your vision?
That's a great question. Same way that we measured the radius of the Earth, I guess, by seeing how far we can see. That's pretty funny. So, like, one existed before the other, right? Like, 3959 in your limit of vision was around before people thought the Earth was a globe. But then people started to be like, hey, wait a second, things kind of curve. And then decided that the Earth was a globe instead of it just being the way that you view the world.
So optics make it look like a globe.
No, that makes the sky is curved. Then you translate it to the ground, which is useful in coordinate systems to make a map. And I think that's where a lot of the hang up is people are like, but I can navigate on a globe. It's like, yeah, because the globe is modeled after your vision, which is, you know, how you view the sky, which is that curvature is translated to the graticule, and then that graticule is used to create every map that you know of, every coordinate system. So, like I'm
So
sure you've
when you
probably
say
heard
your
people say
vision,
before, you can turn the globe
right,
into a fucking cube and still navigate properly, you know? And
you
you'll get all the
mentioned
right answers and everything.
Are you listening, bro? Because I'm going to counter
Yeah,
your
go ahead.
claim. So you're saying vision, right? Are you pertaining all of this to the human eye? Because we have other optics and other lens that measure the same rate of drop.
Yeah, I
Is
don't
this
think it
all
matters
about
what
the
you
human
use.
eye perceiving it?
All the instruments and
It doesn't
I mean, what
matter
do you?
what you use. So it's not
Right, but
dependent on the curvature rate of your lens.
that all things that are optic and all lenses are in the design of the eye. Like it's all in the same shape. So it would interpret the information all the same way.
Yeah, but I can get a camera that has like, multiple lenses that allows for like,
And they're all in
100x
the
zoom.
design of an eye with the curve and it's going to intake the light the same exact way that your eye would. That's why it's designed that way.
Lenses that don't are called.
It's very different from the eye because I can see further and still observe the same rate of drop.
It's the same exact thing as the eye. It's just a larger size.
So the rate of drop is not dependent on how well the lens is cracked.
It's literally the same exact design as the eye. It's just a larger version of it, so you can see further and more.
You're not going to see drop, dude.
No, we measure drop over distance.
No, oh really? Show me where. Show me one instance where you're measuring drop over distance. There is zero drop over distance that you physically measure. Now, you can calculate drop over distance with a formula that gives you drop over distance, but that is not something you will physically fucking do. No surveyor in this fucking world physically measures drop over distance.
That's a lie.
It's like a calculated thing. Because what you're doing is, yes, it is. What you're doing is in that distance, you're going to add a curve of a radius that's supposedly going to be shot down to the center of this earth of your globe world that you believe in. And then you have this radius that's going from this position to this position on the surface of a ball. And then that's going to give me my drop over distance mathematically. But use 1 degree for every 69 miles, which is a planar. Let me get this corrected. That would be
it's not.
Cartesian. Would that be better?
It's a spherical coordinate system, dude. Angles to the celestial sphere. It's not flat.
Oh, you're not listening, bro.
Did you see?
You're really not.
I'm listening.
Okay,
it's really hard to argue against triangles. So like until you guys can like steel man our position, like I think we're gonna keep going in circles. So like you use
used in celestial navigation on the globe. No triangles, no right
but
angles, no right.
Yeah, we're using the stars though, and one thing that's also specific about the celestial theodolite is you need to use a star and a mountain peak that are above 15 degrees or whatever, so you don't have that distortion near the horizon that you get.
You don't need the surface that you're standing on to be any particular shape to measure an angle. I can just establish vertical, and then everything will.
Except when you're actually
Hold on. I don't want to get interrupted like that. Okay, so I can establish a vertical and measure the zenith angle. No baseline, nothing that's truly parallel to Earth's surface, intersecting with the horizon. I don't need any of that. Imagine you're on an asteroid and there is the vector of gravity as you're standing on it. You can create a horizontal plane, which would be perpendicular to your vertical, and then measure an angle. No flat baseline to the GP of the star. You don't need
that's
your
what you guys
horizontal
are doing.
baseline
That's
to measure
why you had
angles.
to run to the stars in the sky, because earlier we were talking about measuring the actual surface.
Yeah, so here's the point, dude. Mathew,
you could literally take an angle while on an asteroid. You do not need the surface of the ground to be a horizontal plane. Your horizontal plane is created by your leveling instrument. It's artificial.
By definition,
and I could just reference vertical, right? I don't even need a horizontal.
By definition, linear. By definition, linear is straight line. By definition. So when you say it's a linear measurement, that means it's a straight line measurement. So the second
linear equation, not linear.
Oh, the linear equation is okay. So tell me this: where in the linear equation is curve? You're the math teacher.
Right. So the linear equation is a straight line, graph between the zenith distance and the distance to the GP. That's the sense in which it's a straight line, not the physical straight line on the Earth, but a straight line in the graph. Maybe an easier way to describe it would be proportional. If you double the zenith distance, you double the distance to GP. If you triple it, you triple the distance to GP, and none of that works in triangle.
Okay. So if you have which makes sense in the world of like we were trying to have a straight line, because that's what it would be over water. It would just be a horizontal. Look at the ocean from left to right. It's just flat. That would be considered a straight line, in my opinion. You might not agree, but whatever. It's not curving away. It's not curving away from you, and it's not curving left to right downwards. It might look like a 360-degree view because of equidistance, around you that your eyes create, because your eyes are curved, and then they create this little edge on the edges of your peripherals. But it's still flat. If you were to put like horse blinders on you, you would see parallel in all directions if you cut off your peripherals. But let me go away from that because I'm still sticking on linear. By this measurement on a sphere, that's every 60 nautical miles is 1 degree. That is even not matching the sphere. It doesn't match it mathematically. So what do? Ironically, they just use it linear. And they say, no, every 60 miles is 1 degree. I go another 6 miles, 1 degree, another 6 miles, 1 degree. Yeah, they use that because it's a planar measurement. But it only works in that way. You can't, because if you introduce a sphere to it, the surface of a sphere, that angle decreases. So like at 6 miles, 1 degree, and then another 6 miles, 2 degrees, and then another 6 miles, 3 degrees. No, it'll be like 2 point or less than 2, and then it'll be less than 3, and then less than 4. It won't give you the measurement you think you're getting. This is probably why they're off, because they're accounting for something that doesn't exist. It's just a mathematical construct. I've been saying that for the past 2 hours.
Yeah, celestial navigation has worked for hundreds of years, where they use the zenith distance times 69 miles to find the distance to the GPS.
And before they started calculating it to be this globe with 69 miles representing a sphere, before that they were able to do that as well. They were able to navigate. Guess what? They got to where they were going, and they came back. And it just worked out perfectly. Well, then you're not on a sphere. You're on a planar surface, and you're mapping it to a sphere using the planar surface measurement.
That's what the self-EO does, man. See, hold on. So you're talking about like getting the right distance here, Matthew, and that's exactly what the self-EO deals with, man. So let's just go through this real quick. This isn't about anybody's beliefs or anything. This is just the method, okay? So you're using the star being occluded by the mountain peak to get an angle. That's it. We're not doing anything else with that. It just creates an angle. Now, everybody knows if you have two sides of a triangle, you can deduce the third accurately. So it doesn't matter, like we use the distance in the self-EO because it allows you to see what the differences are between the two methods, I guess you'll call it, because it's really not methods. The globers are adding extra. We'll just go with this for now. So you got your angle to the mountain peak, and you did that from the star. And now we already know the elevation of that mountain peak. So all you need to do is use those two angles to get your third one, and that creates the distance. Now, there's no scenario in which anything other than a flat baseline gives you the most accurate distance. And what happens is when I listen to Ruhif and other people, what they're trying to do is they're trying to add extra things to get back to our original answer, because that's the correct answer on the distance in the flat Earth. Does that make sense? So you got your angle to the star. You already know the elevation of the mountain peak that is that, and so you use those two things to deduce the distance on the baseline. And only the flat baseline gets the most accurate measurement. Now you can think whatever you want of that.
Dude, when you do the flat Earth trick for the elevation angle to the mountain, it doesn't match reality.
Here's the thing. Okay, hold on. There is a slight discrepancy, and like I said, the flat Earth is the most accurate. There's no way to get a more accurate reading. So when you're talking about dead nuts on exactly 1 foot for 1 foot or 1 inch for 1 inch, that's nearly impossible, because you'd have to get the star to occlude the exact mountain peak, because we know exactly how high these peaks are. So yeah, there's a slight discrepancy, but the problem is that the most accurate one is the flat baseline, and the globe is off by sometimes as much as 10,000 meters. That's 10 kilometers. So like I said, there's no scenario in which anything other than a flat baseline gives you the most accurate distance. That's just the way it is. And that small discrepancy you're talking about is expected.
Exactly. What is very obvious here is that it's very simple to understand that the linear relationship between the distance and this angular height of the Polaris, it's a linear relationship. This will imply that you are in a Euclidean geometry.